Welcome students. In this video, I will continue with the theorems in the circle. I have already proved two theorems and this is the third theorem. There's no need to remember all the theorems. Only the first theorem is enough. What was the first theorem? That the tangent at any point on the circle, this is the tangent at any point on the circle, is perpendicular to the radius. This is the theorem which we need to remember, and rest can be proved. So let's take the third theorem and try to prove it. Prove that in two concentric circles, concentric circles, let's draw two concentric circles. The chord of the larger circle which touches the smaller. It should be chord to the larger, but it should touch the smaller. So this is a chord. It can be drawn anywhere. It can be drawn here, anywhere, but for easy view I will be drawing here only. Okay, so yeah, this is a chord to the larger circle and it touches the smaller circle, is bisected at the point of contact. I have to say this is the point of contact. Let's name this point of contact as C and this chord as AB. So what we have to prove, this is the center of the circle, so it's O. So we have to prove that AC is equal to CB. Okay, so let's join this and this also. Okay, and this also. So AB is a tangent to this smaller circle. Okay, because this is the smaller circle, and this line AB is the tangent to the smaller circle because it's in the question that it touches the smaller circle. If it touches, then it's tangent. Okay, so and is AB is chord to the larger circle, so it's tangent. So obviously this angle will be 90 degree. Theorem 1. Okay, so in triangle AOC and triangle BOC, what we have, AO is equal to BO, both are radius, okay, of the larger circle, and OC is equal to OC, common. Okay, and then we have angle OCA is equal to angle OCB is equal to 90 degree. Okay, so this side was common, these two were radius, and these angles were 90 degree for both. So by RHS congruency, these two triangles are congruent. Therefore, it's implied that AC is equal to CB. It is by CPCT, congruent parts of congruent triangle. Okay. Now let's take another theorem. In this theorem, we have to prove that the tangents drawn at the end of the we have to prove that tangents drawn at the ends of a diameter of the circle are parallel. So this is the diameter. Diameter can be anywhere. This is also the diameter. So if we'll draw a tangent here, okay, this is a tangent and this is also a tangent. Okay, let's this be CD and this be AB. This is the center. So what we have to prove, that CD is parallel to, we have to prove that CD is parallel to AB. Okay, again, as this is a tangent and this is a line joining the point of contact to the radius, so by theorem 1 this will be 90 degree, and again for this also this angle will be 90 degree. So these are alternate angles. So alternate angles are alternate angles are equal, thus both equal to 90 degree. Hence we have CD parallel to AB. Why this was 90 degree? Theorem 1. What was theorem 1? That a tangent at any point on a circle is perpendicular to the radius, okay, through the point of contact. So this was the theorem 1, and this theorem 1 is very important. We only need to remember the theorem 1 and the rest theorems will follow from this theorem only. Okay, next, this was theorem. Now take the fifth theorem. In this theorem we have to prove that the angle between the two tangents drawn from the external point. So this is a circle and this is an external point, let it be P, and tangents, draw a tangent. So we have to prove that angle between the two tangents, this is the angle, this angle we are talking about. Let this be angle 1. Between the two tangents drawn from the external point to the external point to the circle is supplementary to the angle subtended by the line segment joining the point of contact to the center. Where is point of contact? This. So, and where is center? This is the center. So angle subtended by this line joining the point of contact to the center. Angle subtended by this. So which angle? It means this angle. Let this be angle 2. So what we have to prove? We have to prove that angle 1 plus angle 2 is equal to 90 degree. Supplementary means, is equal to 180 degree. Supplementary means the sum of angles is 180 degree. So again, as this is tangent, so we have this angle 90 degree, this angle 90 degree. Let this point be A and this point be B. Okay, so angle A is equal to angle B is equal to 90 degree. How? By theorem 1. Okay, and also we have APBO is a quadrilateral. Yeah, this forms a quadrilateral. So the sum of all the angles, that is this angle plus this angle plus this angle, this and this, will be equal to 360 degree. Okay, that is angle A plus angle B plus angle P plus angle O is equal to 360 degree. And we have angle A plus angle B 180 degree. Therefore we can write angle P plus angle O is equal to 360 degree minus 180 degree, which is again 180 degree. So hence we have proved the final result. Angle P is angle 1 and angle O is angle 2.